Good afternoon. We have today that is lecture on gusseted base. When load is higher one, then gusset base are provided. If load is lesser one, then we will go for slab base. Now again, you can have one problem that is in detail. If you will go to lecture number 21, and if you want to go for theory part, you have to refer lecture number 20, and these are in playlist steel structures. Now we have this problem that is design a gusseted base for a column ISHB 350 at 661 Newton per meter carrying a factorial load of 1700 kilonewton. The column is to be supported on concrete pedestal that is M20. This is M20 grade of concrete and angle ISA 115 150 16 millimeter. So now we will have step 1 given data. Step 1 given data. So we have given ISHB 350. ISHB 350 at 661 Newton per meter. Then we have factorial compressive load 1700 kilonewton. Then gusset angle 115 150 16 millimeters, and we will assume gusset plate 16 millimeter thick. Gusset plate 16 millimeter. Now we have step 2 properties of section. Properties of section. So we have given D 350 millimeters, BF 250 millimeters, TF 11.6 millimeters, TW 8.3 millimeters. Now we have to go for a size of gusset plate. Step 3. Size of gusset plate. Gusseted base plate. Now we have this as 350. Then we have provided this angle. So 150, 115. Actually, this is 115. This is 16 millimeter. So on both sides, we have this will be. So we have width of base plate. Width of base plate equal to 350. This is depth of column plus 2 into 116. This is angle. Sorry. Then we will first go 2 into 16 mm thickness of gusset plate. So we have 2 gusset plate on, that is 1 on each side, 16 millimeter. Then we have this angle 2 into 116. 2 into 116. And then we will get this value that is equal to 350 plus 32 plus 2 into 116. And we will have 614 millimeters. Therefore, provide width of So this is width of base plate, gusseted base plate. So provide width of gusseted base plate. Gusseted base plate equal to 620 millimeters. Now, area of gusseted base required. Same formula, force upon allowable bearing pressure. Force upon allowable bearing pressure. Allowable bearing pressure. Now we have force 1700 upon allowable bearing pressure. We have 0.45 into 20. And we have area required 188.89. 188.89 into 10 raised to 3 millimeters square. And therefore, length of gusseted base required. Gusseted base equal to area upon width. Area we have 188.89 into 10 raised to 3, and width we have 620. And from this we will get length, that is 304.66 millimeter, and therefore provide gusseted base as 310 millimeter by 620 millimeters. Now next we have, that is actual bearing pressure. Actual bearing pressure equal to force upon area provided. Force upon area provided. Force we have 1700 into 10 raised to 3 divided by 310 into 620, and we have this value 8.85 Newton per mm square, less than 9, which is allowable, 0.45 into FCK. And then we have this cantilever length, which is beyond your thickness of angle section. So we have actually this total, we have 620. Therefore, we have cantilever length equal to total we have 620, then by 2. On one side we have, from center we will say, or we will consider 620 minus 2 into 16, which is thickness of gusset plate, minus 2 into 16, which is thickness of angle. And then we will get, this will be total and divided by 2. So we will have 620 minus 2 into 16. We are considering this 620 minus, we have to also subtract this 350. So we have minus 350 also. And then we have 620 minus 32 minus 32 minus 350 divided by 2. It comes 103 millimeters. And therefore we have cantilever moment equal to WA square by 2. And A is this cantilever length. So this is 103. And we have this value, this we have calculated 8.85 Newton per mm square. So we have this cantilever, means if we will draw this, then we have likewise, we have this will be my UDL, we have this as cantilever, and UDL upward because we have soil pressure 8.85. We are considering unit width, so it becomes Newton per millimeter, and length we have 103 millimeters. And therefore we will get equal to 8.85 into 103 square by 2. And this comes 46.94 into 10 raised to 3 Newton millimeters. Now we have MR is equal to bending moment. Now this explained in detail how this 1.2 comes over here. 1.2 ZE Fy upon gamma MO, and that is equal to 46.94 into 10 raised to 3. And ZE, we have taken 1 over here, 8.55 Newton per mm square. We have taken 8.85 Newton per mm. So width we have taken 1 into T square upon 6 into gamma MO 1.1 into 250 equal to 46.9 into 10 raised to 3. And from this we will get T, that is equal to 32.14 millimeter. Now out of this, we have this as 16 millimeters, and therefore we have thickness of gusset base. Thickness of gusset base equal to 32.14 minus 16, that is 16.14 millimeters, and therefore provide gusset base, and that is 310 millimeter by 620 millimeter by 18 millimeters. So now we have connection. So bolts in single shear. Now I will not go. We are well known for this. And we have VDSB 88.73 VDPB. By using this all, we have VDPB that is equal to 129.92. Minimum we have 88.73. And assuming column end and gusset material to have complete bearing, and therefore we have number of bolts equal to force we have 1700 into 10 raised to 3, and we have bolt value 88.73, and we have 1700 divided by 88.73, 19.16. Therefore, provide 10 bolts on both sides. So this is all about your gusseted base on both sides. So now we will stop here only. Remaining part we will see in next lecture. So thank you.